All right, we're looking at another part of polar stuff, and that is converting from rectangular to polar and polar to rectangular form. If you remember, rectangular is just your old-fashioned XY plotting system, also sometimes called Cartesian. Um, so to convert from one to another, I'm going to start by just giving you an example of one where I want you to convert this polar coordinate, I said coordinates, whatever, polar coordinate, um, 3 pi over 6 to rectangular form. And it's a little bit easier to see if we plot the point. So the ordered pair 3 pi over 6 means we find the pi over 6 angle, which pi over 6 is 30 degrees, so we're going about in this direction. And we will move out 1, 2, 3 units. So there is my point 3 pi over 6. That is the polar form. I want to convert it to rectangular form. And the way we're going to go from polar to rectangular is we will have to channel our inner trigonometric skills. So um, what I do know is that that's my ordered pair. R, my 3, is the length of this little red dotted line. And pi over 6, which is 30 degrees, is the angle that I rose up off the x-axis. So there's 30 degrees. And in order to find my xy coordinates, rectangular form means I need the old-fashioned xy coordinates that take you to the same place. So what I'll do is my x coordinate, I'm going to draw a triangle. My x coordinate is however far I go to the right coming off the origin. So there's my x. My y coordinate is however far I go up. So this distance right here is my y coordinate. And in order to solve for either x or y, we're going to use our trig, sine, cosine, tangent stuff. Since I do know the length of my hypotenuse, 3 is my hypotenuse, yes, since I have my hypotenuse, I need to choose a trig function, I forgot my p, I need to choose a trig function that actually uses the hypotenuse. So that means I'm limited to sine and cosine. I don't want to use tangent because then I would have y over x. They're both variables. So what I'm going to do is I'm going to start off for my x, I'm going to say cosine of 30 degrees is equal to adjacent over hypotenuse, x over 3, which means my x coordinate, if I multiply both sides by 3, I know that 3 cosine 30 degrees is equal to x, and then cosine 30 degrees comes off my unit circle. So I'm going to think about 30 degrees right here, and my coordinates are root 3 over 2 and 1/2. Okay, so at 30 degrees, those are my coordinates. Cosine is root 3 over 2. So we have 3 times the square root of 3 over 2 equals x, which cleans up to simply 3 root 3 over 2. And that is the x coordinate. To get my y coordinate, so there was my x coordinate work. To get my y coordinate, we'll do the same type stuff, but we're going to need to use sine because sine of theta, or sine of my angle, 30 degrees, will be opposite, and the opposite leg of the triangle is y over the hypotenuse. And so 3 times the sine of 30 is going to equal y. I multiply both sides by 3, so multiply by 3. And sine of 30 is 1/2, so that's 3 times 1/2 equals y, and 3 over 2 is equal to y. So we're going to use our right triangle trigonometry to figure out my x and my y's, and then we'll simply throw it in ordered pair format. So my x coordinate is 3 root 3 over 2. My y coordinate is simply 3 over 2. And there is your answer. Good, 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 good. I'm going to give y'all a few generic formulas that may come in handy. Using that same thinking, we always start with the polar point r theta, and r is the length of the hypotenuse, or how far away from the origin you traveled. Theta is the angle back to the x-axis. Yeah, that's right. So there's my theta. And if I want my x and y coordinates, my x coordinate goes to the right. Hey, a little hiccup. That was cool. My y coordinate is going to be how far up I go. So I have my y coordinate. I have my x coordinate. And using trig, I can set up all kinds of equations. I can say, well, if I know the cosine of theta is equal to adjacent over hypotenuse. X over r, I could multiply both sides by r, and when I do that, I will get r cosine theta is equal to x. That is one conversion formula. Might be easier for you just to memorize that. I could also, if I could do cosine of theta, I could also do sine of theta is equal to, it'd be opposite over hypotenuse, y over r, multiply both sides by r, just like I did on that last one. And that would give me r sine theta is always equal to y. That's another formula that might come in handy. Now I could also, this doesn't come in handy as much, but if I can do sine and cosine, I could also do the tangent of theta. Tangent is opposite over hypotenuse, y, or opposite over adjacent, y over x. And we can't really do a whole lot with that. We'll just leave it as tangent theta equals y over x. Some other formulas that we could use, getting away from trigonometry. We have r cosine theta equals x, r sine theta equals y. Getting away from that trig stuff. I could also completely ignore the angle. I have a right triangle, and probably the very first formula you ever used regarding a right triangle was the Pythagorean theorem. So in addition to these three formulas, I also know that x squared plus y squared is equal to r squared. Simply your Pythagorean theorem. And that is a formula that we're going to use a lot. X squared plus y squared equals r squared. Leg squared is hypotenuse squared. And I could also have an offshoot of this one. If I take the square root of both sides, r would equal to the square root of x squared plus y squared. We don't use that as much. We will use it sometimes, but usually we use this one where x squared plus y squared equals r squared. What you do not want to do, this is not the same as just x plus y. You cannot take the square root of each piece inside the radical. You have to leave it as root x squared plus y squared. Those are your 5 main conversion formulas. All right, so here they are again. This is just in nicer writing, but these are your 5 main conversion formulas. We will use these quite a bit. We'll use them over and over and over and over again. It would be easier just for you to memorize those 5 formulas, because if you don't memorize them, then your other option is to go through and actually draw the triangle every single time like we did here on this first example. So using these 5 main formulas, let's do some conversions. And let's convert these 3 polar points into rectangular. That means we have an r and a theta, and I want to convert to x and y. Now, assuming you haven't already memorized those formulas, I'm going to paste them right here just for us to be able to peek at. You do need to get to where you don't have to, you do need to get to where you have that memorized. But these are the formulas we're going to use. If I have polar points to rectangular, that means I want to go from r theta to xy. That's my goal here. And in all of these cases, I gave you an r and a theta. Well, the easiest way to get x and y from r and theta is these 2 formulas right here. X equals r cosine theta, y equals r sine theta. So if I know that r is 5 and theta is 150, I know that x equals 5, which is r cosine of 150 degrees. Cosine 150, got to think about the unit circle. Let's see, let me draw it down here. There it is. 150 is about right here, and your coordinates are negative root 3 over 2 and 1/2. Cosine is the x coordinate, so x is going to be 5 times negative root 3 over 2, which is just negative 5 root 3 over 2. There's my x coordinate. My y coordinate is r sine theta. R is 5. Sine of theta, which is 150 degrees. And sine of 150 is 1/2. So y equals 5 times 1/2, or 5/2. So I'll simply take those 2 ordered pairs, that x and y coordinate, and you get 5 root 3 over 2 and 1/2, or 5/2. So this rectangular point, that's an x and a y, is the same point as the polar coordinate 550 degrees. And then we're going to do the same thing for these other 2. Move my unit circle down. X equals r cosine theta, so negative 4 cosine 7 pi over 4. So we got to think about the unit circle. 7 pi over 4 is down here. And your coordinates are root 2 over 2 and negative root 2 over 2. So we'll see. So x is going to equal negative 4 times positive root 2 over 2. That's my cosine. Let's see, 2 goes into 4 twice, so that cleans up to negative 2 root 2. My y-coordinate is going to be negative 4 times the sine of 7 pi over 4. Sine of 7 pi over 4 is the y-coordinate in my unit circle, so y is going to equal negative 4 times negative root 2 over 2. Again, 2 goes into 4 twice. I have negative 2 times negative root 2, which is positive 2 root 2. So the xy ordered pair for number 3 is the x-coordinate of negative 2 square root of 2 and positive 2 square root of 2. Good? Good. Simply plug into these formulas, x equals r cosine and y equals r sine. Last one, 3 pi over 2. X equals 3 times the cosine of pi over 2. Cosine of pi over 2 is 0, so that's x equals 3 times 0, which is 0. Y is going to equal 3 times the sine of pi over 2. And 3 sine pi over 2, sine of pi over 2 is 1, and 3 times 1, if you know your 1 times tables, is 3. So that turns into the ordered pair 0, 3. Went through that one kind of fast, but you're just plugging into the r cosine theta formula. I chose this one for a reason. This one, if you are good at graphing, I'm a graph thinker. The ordered pair 3 pi over 2 means in the pi over 2 direction, I need to go 3 units. That's how you plot an ordered pair. Well, all I did is go straight up 3 units. I don't need conversion formulas to know that if I go straight up 3 units, that's the xy ordered pair of 0, 3. So some of these, if you can graph the ordered pair, you might could figure out the rectangular points simply by looking at the graph if it happens to fall on one of the 2 axes. Okay. The more complicated conversion is going from rectangular to polar. It takes a little bit more time and a little bit more brain power. So here are my formulas. This time I gave you an x and a y, and I want to convert that to an r and a theta. Okay, this is a little bit trickier. The first thing we're going to do is find r. So we need to find r first. And in order to find r, I'm going to use that Pythagorean theorem. I know that x squared plus y squared equals r squared. X squared is x is 1, so 1 squared plus the square root of 3 is my y squared equals r squared. 1 plus 3 equals r squared. 1 plus 3 is 4. Square root of 4 is 2. So we get 2 to equal r. Well, I'm halfway there. I know that r is equal to 2. What I don't know is my angle theta, and this is where it gets a little bit trickier. We have several formulas here that have theta in it. We could use tangent, but I don't like tangent because it's not explicitly on the unit circle. I prefer sine and cosine. So what I'm going to do is simply take one of these 2 formulas. Doesn't matter which one you choose. I'll just go with the top one. And I know that x equals r cosine theta. And then I plug in what I know. The x-coordinate was given, that's 1, equals r, which I just found out was 2, times the cosine of theta. And then we need to solve for theta. So I'm going to divide by 2. You get 1/2 equals cosine theta. And we could throw that in the calculator, but I'm pretty smart. I know that 1/2 is all over the unit circle. I just have to find the place where the x-coordinate is 1/2. That happens, that was a bad unit circle. That happens up here. I have coordinates of root 1/2 and root 3 over 2. That's at 60 degrees, or pi over 3. It also happens down here at the angle of 300 degrees, which is, geez, brain fart, 5 pi over 3. The coordinates right there are 1/2 negative root 3 over 2. So there are 2 angles where my cosine is equal to 1/2. We have to make sure we choose the correct one. So here's what I'll do. I'm going to think really hard. If x and y are both positive, x equals 1, y equals 3. If x and y are both positive, I know that this ordered pair is somewhere in the first quadrant. So I'm going to choose the angle that is in the same quadrant as the ordered pair. That's 60 degrees or pi over 3. So I know that this theta is going to be pi over 3. Now, if you punched in the calculator, you might get 5 pi over 3 as another option, but we throw that one out because it's in the wrong quadrant. So my final ordered pair is going to be 2 pi over 3. So once you get your theta and your r, there we go. Good, good? Good, good? Let's do one more. I was going to do 2 more, but this video is getting kind of long. So let's do this one. This is going to be the last one. We have an x and a y. I want to convert to r and theta. And I'm going to start with x squared plus y squared equals r squared. And this one's going to be a little bit hairy. We have negative 3 root 2. That's my x squared plus my y is 3 root 2. We'll square it equals r squared. And when you square something like this, negative 3 squared is positive 9. The square root of 3 squared is 2. Plus 3 squared is 9. The square root of 2 squared is 2 equals r squared. That's 18 plus 18, which is 36. Whoops. And take the square root, and you get your r to be 6. Okay? So I know that if I'm going to convert this to r theta, I know now that my r is 6. I have to find my theta. So I'm going to go with either r sine or r cosine. I usually go with, I know that x equals r cosine theta. I don't know why, but I just choose that one. The x coordinate is negative 3 root 2 equals r, which I now know is 6, times the cosine of theta. I will divide both sides by 6. And we will reduce this fraction. 3 goes into 6 twice. Those 6's cancel. So I've got negative square root of 2 all over 2 equals the cosine of theta. And negative root 2 over 2, that happens all over my unit circle at 45-degree angles. I need cosine to be negative. That means I'm looking either at the angle, that would be what, 3 pi over 4? Or my angle in the third quadrant, 5 pi over 4. That's a stupid looking 5. In both of these ordered pairs, my x coordinate is root 2 over 2, or negative root 2 over 2. In the fourth quadrant, why can't I get my quadrants right? In the third quadrant, it's negative root 2 over 2, negative root 2 over 2. So we have 2 angles, 3 pi over 4 and 5 pi over 4. We have to choose the angle that fits this ordered pair. We'll see if my x and y are both negative. This is in the third quadrant. X and y are both negative, so I want to choose the angle that's in the third quadrant, which is 5 pi over 4. And once you get your angle, and once you have your r, you plug it into the ordered pair, r 5 pi over 4, and there is our answer. You good? There we go. Have a great day.